And all right, so the next thing. So when you go to the side, I graph this in, remember, algebra mode, which is the button with looks like a calculator. And you type in the equation. You can plot points if you just use the function notation, which is nice. So h of 3 printed at 144. I went to geometry and I grabbed the axes a little bit with the move button. So move graphics move, and I grabbed some axes up and down, left and right to make it a, a nice descriptive picture. The next piece is I am going to insert a point at a certain location. And because I want it to be a little bit different than what you guys are doing on your lab, I mean just a little bit different, I'm going to go to 1. So I didn't want to do it entirely on your behalf. So the point h of 180 is a point you can actually plot points. If you put a parenthesis and I type in 1 comma h of 1, it makes a point on the graph at the location that you desire. So it's calling up function h, putting 1 in it at x equals 1. What I'm going to do is, like in the lab, it asks you to do the secant line thing and just make it closer and closer. It's a duplication of what we've done, but it's using software to make it happen. Then you're going to take another point out somewhere on the curve, and you're going to slide it closer. So we can do this in a cool way. We can actually insert what's called a slider. So you can slide something to make it go back and forth and make it closer and farther. And the way you insert a slider is actually to put in, here, first I'm going to put in the word slider, right there. And all these things pop up. It's definitely too much information. I'm only going to use 3 of these fields because I can do things with sliders on here that are just wild. Like you can go, there's a lot of parameters in there. What you're getting is a suggestion for things that you can do. For my slider, I'm only going to put in my lowest value, my upper value, in my increment of how big I want it to be, and hit enter. So I'm going to do that again here in a second. So it makes a slider out of that. So I'm going to delete it. Show you one more time. You type in the word slider. Okay. Parenthesis, lower bound, upper bound, that you want the slider value to go between. It's just an adjustable value. So 0, 1 or 0, 3. I want and then the third component, the third parameter is going to be the parameter. I'm sorry, the step size. When you slide it, it's going to go, each little move is going to go a certain increment. I'm going to make them pretty darn small because the smaller you make it, the more precise it becomes. And when I hit enter, it's called B, and it actually inserts it into the picture so that I can literally grab it with my cursor or my pointer and I can slide it. The next is I'm going to put a point on my graph based on that slider value, which I'm going to make a little bit bigger than 0 for right now. But watch this next point. I'm going to go parenthesis. I'm going to put, instead of a number, I'm going to put B, the slider value. Okay, so that's how far off. That's and I'm going to add it to my current x value, b plus 1 or maybe 1 plus b. Either one's fine. But I'm adding to the current x value that I have, which is x equals 1. I'm going to add the slider value to it, comma. Then I'm going to put that into my function and get a point. So that means I am plotting a point at 1 plus b, whatever b is, in this case 0.62. Then I'm going to put that into the function to get a y value. This is an x and a y value based on my slider. And there it is. Now, the cool thing of making a dynamic point like this and hit enter is that if I move my slider, I move my point. So it rides along there. So I'm programming in this point that moves at my will. It bends to my will. Isn't that cool? Back and forth. Now, that is part of the process. We did this before. Remember, so the secant line, we're literally going to shrink it with that slider until it's smaller and smaller, and you're going to look at the slopes. And I'll give you, it's a dynamic, fun way for you guys to see those slopes take place. Graphed it. Put a fixed point at 1. By the way, your lab is to fix a point at 2. And then you make a slider. The slider, if you type the word slider, it gives you all these parameters. You just do the first 3. Lower, upper bound, and then the step size. I put 0.001. And then the final component is I'm going to put a line between these, the secant line. And that's under geometry, the middle tab, under tools. If you scroll down to the bottom, if you haven't hit the more button, you need to hit the more button because you want to hit to segment. So let me find that. And if you hit enter on segment, you'll find out how an annoying fact, that piece of GeoGebra is about to happen. You click on it, and you just connect the lines with the segment. So I go click on A. Now you click on B. Voila! I got a segment. Here's the annoying part of GeoGebra. If you click anywhere else on the graph, it's going to make a new segment. So it's like when you put your hand into something sticky, it just keeps sticking everywhere you go. So the only way to disengage that is, one, it's really annoying. It literally is. It's like watching Christmas Vacation, which, by the way, this made me think of Cousin Eddie today when I put it on, because it kind of have a little bit of I always like that. And he wore a cool belt. It's getting me in the mood. Okay, so we'll talk about that later. The undo button is right here. No matter what, hit undo, and you can undo. To get it to stop sticking secants everywhere you touch, like glue, you have to go up to click on this cursor button. So I'm going to walk you through that again because it's annoying. It's one of the features that used to drive students nuts when we use this a lot in one of my classes, geometry. You go to segment, which is under lines. You connect A and B. That's great. And if you don't disengage that, you're going to make segments anywhere you click. Super annoying. So you go up here to click on the move tool, and you disengage. You engage this innocuous pointer. We like the pointer. Pointer's good. Now that that's in there, we can look at that segment just travel anywhere I move the point. Hey, the F is with it. Now that's not what we're really interested in. It is fun to look at, though. This is what we did when we did the limit definition of derivatives. We just kept sliding it closer and closer. If I had my druthers, I think I can right-click on this. I think I can change the name to H, but I would almost be misleading. I'll think about this later if I want to do that. But I'm sliding it back and forth. I'm going to get the slope calculation on here. It's in here. It's free. So I can go down, there's a measure section, angle, distance, length, area, angle given, slope. So if you click on that measure thing, it says slope of a line. All you have to do is click on the line you want the slope of. Ta-da! It clicks and it has it for you. So I clicked on that, 28.28. With that engaged, and if I move my slider now, everywhere I slide this. Now don't mind that little triangle. I'm not a real big fan of that little triangle that's in there. What it's doing is showing you a run of one and then the slope, regardless of how long your segment is. So just focus on the M part of it. In fact, I think I can even turn that little graphic off, but it does give you a pictorial image of slope. But right about here, you start seeing the slopes changing over time. It's headed somewhere. So we did this last time mechanically, and we entered it in our calculator, and that's still pretty efficient. But it's kind of cool to see, all right, it's getting closer, closer, it's heading somewhere. I'm getting closer and closer and closer and closer and closer to something. And then I land on the point, and it seems to disappear. So the thing that we need to do is get close enough to start making judgments on what on earth is that headed toward, because that value it's headed toward is the slope of the tangent line at x equals 1. So you want to guess what it's headed toward? Anyone have a thought on this one? It's in there. 60. How close are we going to get? 63.7. Oh, so close. 63. So do you think the slope is 63.76? Is this? Would you guess 64? If you had to, might not be a bad guess. So therein lies an opportunity. We can find it exactly by using the definition that we have up here, which I'm going to employ right now. So this is the start to the lab. I'm also going to go and use the limit definition of derivative, which could help us find this, and then we're going to rock and roll. So I'm going to stop my recording. That was enough to get people started on GeoGebra, I think.